so all right. So what we're gonna do is we're gonna talk about extrema. Extrema are the highest point and lowest point in the interval. So extremas. So what is extrema? The highest point and lowest point. You guys know that, right? Okay. So in order to there is a extrema value theorem. Sorry, extreme. So extrema, and so it's the highest and the lowest point in the interval. So there was an extreme value theorem. So let's start with what's extreme value theorem. So you guys already know about IVT. So let's review. IVT is intermediate value theorem. It's basically you have a value here and you have value here. If it's continuous, it has to go value in between. So that's IVT. But this is the EVT. This is the least popular one, but it's still tested every once in a while. IVT is more often tested. IVT and EVT is more often tested. So you have to be careful with those one. EVT is not as often because it's very intuitive. So basically EVT says if f of x is continuous between A to B, then f has both minimum and a maximum. On the interval. On the interval. And you're gonna be like, wait, what does this mean? So let's worry about a case that doesn't work, right? The case that why do you need those conditions? Why does it has to be why does it need to be like a continuous why doesn't it need to be continuous and on a closed interval? There's two conditions. They have to be continuous and they have to be in the interval between A and B. It has to be closed intervals. So for example, I'm gonna give you a situation is counter example where EVT doesn't work. So at this two cases is not working. The reason it's not working is because they don't have the condition. So for example, I'm gonna give you a very simple case, a straight line. And the straight line is gonna have this, and it's gonna have two holes at the endpoints. Is there maximum value, minimum value here? Well, why no? Because you can claim that circle is going to be your maximum minimum value, right? So let's just say this is 3. How do we know our maximum value is going to be at 2.9 or 2.99? Okay, Alex, focus. Put your computer away. So how do we know it's going to be like 2.9 or 2.99? We don't know is whether 2.9999 or 2.99. We cannot define that. So there is no maximum in the situation. And there was also no minimum because we did not fulfill this condition. The condition says it has to be closed intervals. It had to including the value. Continuous the whole way, including the endpoints. Okay. Now, why is this important? It has to be continuous between A and B. What if I have something like this? So those are the counter example that doesn't work. So if I have this, and I have a open circle here like this. And then, so we don't know where the minimum value here because it's not continuous. because we have open circle. Or even at worst, there's asymptote, right? Asymptote is even worse because there's not continuous. You don't know where the minimum value is. So asymptotes are worse than whole, but whole it'll be a better example actually because we don't know. Asymptote is really easy to tell. There's no minimum or maximum. So there was no minimum here. So there was no minimum. And there's no max and min. Okay. So the way that works is it has to be something like this. Let's just say it has to be something like this. So this is continuous. Obviously, there is a minimum and there's maximum. Because I hear this point here. Now there's two for here. We gotta be careful. This is gonna be relative min. And this point is relative max. And this point is relative min. So the categorize of relative means it has to be decreasing follow with increasing. You cannot just decreasing all the way to the end and you say that is gonna be a relative. No, relative has to have two actions. It has to go down and up or up and down. You cannot be just straight up to the end point. That point doesn't count. So that is called absolute, but in this case, relative has to have two actions. Now for different textbook, let's say in today you're gonna go to England, Cambridge to study, whatever, or going to different country to study, they don't call it the relative, they call it local minimum and local maximum. So they call it like that, especially British system. Now, this particular point is actually a maximum, but it's not relative. But we're going to call this one absolute because that's highest point on the interval. It's called absolute maximum. So the lowest point on the interval at this particular case, not only relative minimum, this one's also absolute minimum. Okay. So this one can be relative and absolute at the same time. And the point here is also known as endpoint extrema. The endpoint extrema at this case is absolute maximum. Absolute, which is the highest. So if I say absolute, then it's going to be highest. So in terms of British system, they actually call it global. They will call it local for relative and global for the absolute. In the AP exam, they call it relative and absolute. So it doesn't have a, it has, just different name. Any question about this part? Everything's okay? It's very intuitive, very easy. It's not hard. Any questions before I move on? Okay. Now, sometimes AP exam don't ask you where does the maximum value occur. They ask you maximum value. So if they ever ask you absolute maximum value, now value represents the output. So the best way to put value here is actually draw a line right here so that way you know every time you talk about value equal to the y value. So it's the output, not the x. If I ever say it's absolute maximum value, in this case will be 5. The value is equal to 5, not equal to 10, because 10 is what it occur, but the value is going to be 5. Minimum value here is going to be -6, because if AP exam ever asks you value, then you have to say that's YU. That's why I draw a line here. It's yu, not like a value. So yu. So value equal to y value. Make sure you know that on AP exam they look for that. So they ask you, hey, what's the absolute maximum value? You're gonna give it a y, not an x. Okay, so make sure that, because a lot of times AP exam, what do they want? At the end of the day, you don't have to know too much calculus. You just have to know how to beat the AP exam. So that's why I don't agree with AP exam. I think AP exam's stupid. But if you know the rules, you can beat them. The only thing you care about is beating the rules, beating the rubrics. Okay, so we're gonna talk about a lot about that today. I'm gonna find out the definition of critical number. So this is the definition of critical number. Number. So definition of critical number says basically there is two definition. Usually people forget the second one, but this is f prime of c is equal to 0. The c is known as critical number. We done this before. When did we done this before? When we're finding what? On the derivative test. When do we look for f prime c is equal to 0? No, almost. What? Horizontal tangent. Good. So when we're finding horizontal tangent, is the slope is equal to 0. You're on the horizontal, but it's not horizontal asymptote. Horizontal asymptote is limit x approach infinity. What happened when do the end? What value I'm gonna give to? Am I eventually gay at the end? Remember that? So am I plateau into a number? Not just going straight up. If you're going straight up, there's no horizontal asymptote, but it's going to like eventually to something. The second definition is f prime of c is undefined. Where is undefined? You're like, wait, what do you mean by undefined? Because that can also be another definition of horizontal asymptote, another definition of critical number. But this definition happens very rarely. It does happen and happen in special cases, but you do need to worry about that. But usually what we did in the back is about vertical tangent. Vertical tangent when it's f prime of c is not differentiable. So usually occur in vertical tangent. And this is the horizontal tangent. But if you have a prime critical number, basic, this is gonna be like f prime of c is equal to 0. Now drawing is gonna look like this though. Drawing is gonna look like this. Well, this, oops, bad. This is f prime of c is equal to 0. This is the c value I'm concerning about. This is the x value, which is set the derivative equal to 0, solve for x. Am I going too fast? And in this case, it's a little bit different. Is take a derivative, find a way and define. So it's like this. This is also f prime of c is equal to undefined, which is not differentiable. So absolute value could be one of them, right? Absolute value could be like a critical number because it's not defined. Or this is called a cusp. This is called a cusp, or as known as vertical tangent. Usually occur where the cusp is you got even over odd power. Even over odd power. Now, one more thing you need to know. If you have relative min and relative max, occur only at a critical number. Only in that critical number. Why is that? Because you have something like this, right? This is a critical number, right? And that's a relative minimum. But here's the thing, it's not the other way around. If you have a critical number, it does not imply it's relative maximum minimum. Can you give me a counter example? Can you give me an example where that's it? Yes.
Like because you should overwrite it.
Well, this is a maximum. This is a maximum. So can you give me an example where derivative is equal to 0, which is slope is equal to 0, but it's not relative maximum min? Yes.
Just a flat line.
Sort of. Yes, Maddie. No, not stop. For example, y equal to x cubed. Slope is equal to 0. But it's not a maximum minimum. So it's like all square are rhombus, but not all rhombus are square. I don't know if you ever heard that term before. So if you have minimum and maximum, must means it f prime of c is equal to 0 or f prime c is undefined. But if you have f prime c is equal to 0, it doesn't imply that's maximum minimum. Yes. So it does not mean so it's only work one way, doesn't work the other way. A lot of time you have to be very cautious of this type of question. Only work one way, but doesn't work the other way. Okay, so let's talk about how do we find extrema on closed interval. There's 4 steps, and this 4 step is very, very important. AP exam very, very look for this. I'm gonna try to teach you start from what AP exam is looking for. AP exam is looking for this, is the guideline to find.
This is a drill. Lock down. Lock lights out of sight. This is a drill. Lock down. Lock lights out of sight. This is a drill.
Gotta find critical number here.
At this time, we are all clear from our drill. Again, we are all clear from our drill. You may resume normal activity. Thank you for your cooperation.
Brian, can you tell me like? So I find the critical number. At this case is 0, and you need to know how to factor. I think today I see a lot of people don't know how to factor to find the time to reach the ground. Always factor out a negative GCF. Factor out first, the number gets smaller, and then you factor more. Hopefully you did that. GCF is a 4 if you factor out. Now, this is an x and this is an f of x. This is a table we are talking about. And this table is super important. Table is important for AP exam justification. So if ever AP exam asks you to justify where is the maximum is in the interval, you have to do it intervals. And this is how you win points. Unfortunately, we play by the rule, we're gonna win. But if you write an essay that says why this is the maximum, they don't give you points. This is a justification. This is what they want looking for. They want you including the endpoint, which is -1 to 2. It must including the endpoints. But in this case, it seems like it's every single point because this is the endpoint and this is the endpoint. And you must include critical number. In this case, it's 0 and 1. So it seems like every single point I'm evaluating. But this is only in this example. The next example we're going to do my skip sum number. So it seems like this is all whole number. I just evaluate all the whole number. That's not true. Only evaluate certain thing. Critical number and endpoint. That's it. In this case, it happened to be every single value. If I plug in -1, I'm going to get 7. If I plug in 0, I'm going to get 0. If I plug in 1, I'm going to get -1. And if I plug in, this is 16. So remember, f of x are the value. So in this case, this is the highest value. So it's absolute maximum value. Does that make sense? That's the highest one. Which one's the lowest one? -1. So the -1 here is the absolute minimum value. If we where they occur at 1. But what's the value? It's a -1. So you compare the table, you just make sure they pick the highest value and lowest value. Is that okay? What time we get off here? F of x is right here.